Let me use more examples to illustrate how to use the 3 qualitative rules to predict the entropy change of the system. I call them advanced examples. There are 2 reasons I call them advanced examples. The first reason is that there are 2 or more factors that can affect the entropy of the system simultaneously. You have to make a choice which factor dominates, like our example number 4. The second reason I call them advanced examples is that you may need to know prior knowledge in order to answer the question properly or correctly, like our example number 5. Example number 4. Is the entropy change of the following reaction delta S greater than 0, smaller than 0, or equal to 0? A balanced chemical equation is provided to us. If we want to use rule number 1 to predict the change of the entropy of the system, we have to compare the volume of the reactants to the volume of the products. As we have learned in class, the volume of the liquid and the volume of the solid are much smaller than the volume of the gas. This problem does not mention any change about the temperature and pressure. Therefore, we will assume that the temperature and pressure are constant during the chemical reaction. From the ideal gas law, if the temperature and pressure are constant, the volume of the gas are proportional to the moles of the gas. Therefore, we only need to compare the moles of the gas reactants and the moles of the gas products if we want to compare the volume of the reactants and the volume of the products. From the balanced chemical equation, we have 25 moles of gas reactants and we have 16 moles of gas products. Therefore, the volume should decrease during the chemical reaction. According to rule number 1, when the volume decreases, the entropy of the system decreases. Because we assume that the temperature and pressure are constant, we will not use rule number 2 to predict the change of the entropy of the system. We can use rule number 3 to predict the change of the entropy of the system. If we want to use rule number 3, we need to compare the number of moles of the reactants and the number of moles of the products. We have 2 plus 25 equal to 27 moles of reactants. And we have 16 plus 18 equal to 34 moles of products. If we want to use rule number 3, the entropy of the system should increase. Now we have to decide which factor dominates, the volume factor or the number of moles of factor. In this case, the volume factor dominates. Therefore, delta S less than 0. Example number 5. For the following process, is the entropy change of the system delta S greater than 0, smaller than 0, or equal to 0? Part A. A precipitate of calcium carbonate forms when solutions of calcium nitrate and sodium carbonate are mixed together. We have a chemical reaction. Therefore, we need to write down the balanced chemical equation. Calcium nitrate contains nitrate ion. Therefore, it is soluble. We put AQ behind calcium nitrate. Sodium carbonate contains sodium ion. Therefore, it is soluble. We put AQ behind sodium carbonate. Calcium carbonate is a precipitate, so it is insoluble. We put S behind calcium carbonate. This is an exchange reaction the other product is sodium nitrate. As we have learned in class, the net ionic equation is the best way to represent what happens during a solution phase reaction. So, we will write down the net ionic equation before we make predictions of the change of the entropy of the system. Calcium nitrate is soluble and it is a strong electrolyte because it is an ionic compound. It is between metal and nonmetals. Sodium carbonate is also a strong electrolyte and it is soluble. Therefore, it will produce sodium ion and calcium ion. Calcium carbonate is insoluble, so it will remain in molecular form. This equation is called complete ionic equation because it contains all ions. And this equation is called molecular chemical equation. Nitrate ion and sodium ion appear on both sides in identical form. Therefore, they are spectator ions. If you want to get the net ionic equation, you have to remove all the spectator ions from the complete ionic equation. This is the net ionic equation. From the net ionic equation, we can see that the number of moles decreases because we have 2 moles of reactants and 1 mole of product. According to rule number 3, the entropy of the system decreases. We can also use rule number 1 to predict. The ions occupies larger volume in the solution than the insoluble precipitate. So the final answer is delta S less than 0. Part B. Hydrogen gas is produced when a piece of zinc is dropped in a hydrochloric acid solution. Again, we have a chemical reaction. We need to write down the balanced chemical equation. And this reaction occurred in a solution. So, we need to write down the net ionic equation. Net ionic equation is the best way to represent what happens during a solution reaction. If we want to use rule number 1, we have a 1 mole of gas product. We do not have gas reactant. Therefore, the volume increases. We can also try to use rule number 3 to predict. According to rule number 3, we have 3 moles of reactants and 2 moles of product. The number of particles decreases. But we already learned that from example number 4, the volume factor is the dominating factor. Therefore, the final answer is delta S larger than 0. Part C. Solid sodium acetate is dissolved in a cup of water. The temperature of the mixture drops. Another process involves a chemical reaction. We have 1 mole reactant. We have 2 moles of product. According to rule number 3, the number of particles increases. So, delta S larger than 0. Somebody may argue that, Dr. H, the problem told us that the temperature of the mixture drops. According to rule number 2, delta S should be less than 0. But I will tell you, your analysis is wrong because we are asking for the entropy change of the system. And for a chemist, the system is always the chemical reaction. The mixture actually is the surrounding. Therefore, you're trying to judge the change or entropy of the surroundings, but we are only asked for the entropy change of the system, so it doesn't matter. This is our final answer.